Everyone, let's start this session by discussing about assembler directive. We have said assembler is a program which will convert a source program into object program, right? So we have used assembly language, we have discussed about the mnemonics, right? So now we need some instruction which can direct the assembler to do some task, and that instructions are called as assembler directives. For example, if we want to assign some value to this sum, then we can go with an assembler directive called as equate EQU, which will equate the value of 200 to sum. So wherever in the program, if we come across sum, automatically it will be allocated the value of 200. To say this equate, we will be going with an assembler directive called as EQU, equate. Let's continue with the program which already we have discussed, that is adding the n numbers using indirect addressing mode. So now R2 is acting as a pointer, right? So you can see here adding the content memory location, right? The R2 is holding, it is acting as a pointer which will be pointing to the memory location. The content has to be fetched by that location, it will be added with R0, right? So now R2 is acting as a pointer, R1 is acting as a counter, and R0 is used to hold the final sum. Now you can take any number. For example, in this example we have taken n is equal to 100, nothing but the 100 numbers we are taking to add them. After that, after every addition we will be keep on decrementing, right? So that is R1 is acting as a counter, it will be keep on decrementing until the counter becomes 0. Right, so after the addition is done, the result will be stored from R0 to sum. For this sum, we have given the memory location 200 where your result has to be stored. Next, the n is equal to 100, the input data what we have taken, it is stored in the memory location 204. The different input data what we have taken, they are stored in the different memory location. This is the memory address we have shown. So here we have shown the memory addresses where the instructions has been stored. For this memory address where the instruction is, where the instruction and the data has to be found, right? The data has to be loaded once the program is loaded for execution. For this memory address, if the assembler wants to produce an object program, then should know how to interpret the names, where to place the instructions in the memory, where to place the data operands in the memory, because the function of a assembler is to convert your source program into object program, right? For the better understanding only, we have taken this example where we are trying to add the n numbers, right? And my addressing mode we have used is indirect addressing mode. For that memory arrangement what we have shown, for this memory arrangement what we have shown, now we have to write an assembly language representation. So now we have used the assembler directives, the instructions we have written over here. The first sum EQU 200 is your assembler directive, right? EQU is your assembler directive which is saying equating 200 to sum. The next assembler directive we have taken as origin. So this origin is the assembler directive which will tell the assembler program where in the memory to place the data block, right? Where in the memory to place the data block, that is the input what we are taking, where it has to start. In the memory arrangement what we have taken, see the data block is starting at 204, right? The data block is starting at 204, that is what we have written, origin 204. Now after this 204, after this 204, whatever the locations we have taken, of course we are storing the different input data. Now you can see n we have said we have taken it as 100, so which is a data word, right? But it is 8-bit, so it is more than 8 bits, so that is why we are taking it as a data word. And n is equal to 100, what we are assigning, that is assigned by a assembler directive named as data word. So EQ or equate is your assembler directive which is allocating 200 to sum. Next it is origin which is saying where to place the data, that is at the location 204. At the 204 we have stored the value of 100 for n, so that n is equal to 100 is done by a assembler directive data word. So this one 200, 204, and these are the locations where the different data has to be stored. Next one, you can see num1 reserve 400. From number 1 what we have taken, we are reserving the 400 memory locations. We are reserving 400 memory locations we can so that we can store the different data we are taking. After that we have taken the next origin. So this next origin is saying about the instructions of the object to program, where it is starting in the memory. Now you can see here the program instructions, the first instruction is starting at the location 100, that is what we have written, origin 100. Then we have the part of the program, so this one, these are the statement which are your machine instructions. So now we have taken the input, we are moving into R1, that is why it is acting as a counter. Next moving the number first to number to R2, then initially we are making R0 is equal to 0, then we are taking the data fetched by this memory address given by R2, pointed by R2, adding with R0 and storing back the result in R0. To go to the next location we are adding 4. Right now we will go to the next location, we are adding 4. We will decrement the counter and we will check out if it is greater than 0, we have said branch, if it is greater than 0 to loop, right? Then once this addition is done, you can move the result which is present in R0 to sum, right? So these are the different location or the addresses what we have assigned, which has been shown here. So this is the section where you are storing the data block, and this is your program instructions where it is starting. Therefore the program instructions are starting at 100 and the data block is starting at 200. The next we have the assembler directive end. So this end is saying that this is the end of the program. Now you can see here it is written end start. So start is the label here we have used where your actually program is beginning, right? So end start is saying that this is the end of your source program text. Now we have one more assembler directive, that is return. So this is the directive which identifies the point. This assembler directive identifies the point at which the execution of the program should be terminated. The execution of the program should be terminated. So now we have used the different assembler directive. EQU is the equate, right? Origin is to say where your data block is starting and where your program instructions are starting. Now you have used the data word which is assigning the value 100 to n. Now reserve is to reserve the memory locations. Again the origin is to say where actually the program instructions are starting. Now this is all your statements which are till move, they are the instructions that constitute a program. Next we have return and end. So end is to say about this is the end of your source program, and return is the directive which identifies the point at which the execution of the program should be terminated. So this is the assembler directives, how they are directing the assembler to perform some task.